Hello, this is Mr. Jarrett, and in this video I am going to be taking you through the hole types and thread reading presentation. The first type of hole that you are familiar with is actually called the drilled hole. So a lot of times it's labeled as the through hole, okay, and they abbreviate it like this. This is just your basic hole, okay, that we draw a circle and we cut through something. So what I have here as far as the pictures go, so you can understand this going further, I basically just drew a block in SolidWorks, drew a circle and cut it through so that you can actually see the interior of it. So this is also like a half section, so you can see the inside of it. Okay, so this is just your basic hole. Now, how you actually read that is like this. So we have the diameter symbol, which we should already know, okay, its measurement, and then it says through. So that indicates that the hole is through, okay? If you don't see this through, it's also assumed that it goes all the way through. Typically they don't put this just for the basic drilled hole, but your diameter, the size, and then through. Okay, now you also have what's called a blind hole. So a blind hole means that you cannot see it from one side. So on this top side, you would be able to see that's a hole, but you can't see all the way through. Obviously on the bottom, you don't even know there's a hole there. So it's blind because you can't see all the way through. Okay, so there's two different ways that a blind hole can be represented. It can have a flat bottom, or your typical bit that comes to a point, like a brad point, would drill a hole similar to this. Okay, so some realistic examples. A flat bottom drill bit would have a flat end to it. Okay, a pointed drill bit, like a brad point, would have this little pointed end to it. So a realistic example would be like if you ever need to assemble furniture or two pieces of wood that have dowels in them. Sometimes the dowels are cut off flat. Some of them are just curled or sanded a little bit at the end so that glue has some room to move in there. But a blind hole would be a hole that doesn't go all the way through so that you can hide connecting pieces like dowels in between. Okay, so how you would read a blind hole is very similar to what you do for the drilled hole. You still have your diameter and whatever size it may be, but then there's this symbol. Okay, it almost looks like a flat line with an arrow pointing down. This is called your drill depth, okay, your drill depth, or thread depth, which we're going to learn later on, but your drill depth. Okay, and the measurement of how far down it goes. The next type of hole is called a countersink. Counter meaning it's moved down inside, okay, and sink is an easy way of remembering this because this kind of looks like a funnel, almost like your kitchen sink or any type of bathroom sink or sink in general. If you pour water into that sink, if it's built correctly, it should funnel the water down to a hole. Okay, so the example here that I have for you has the countersink top with a drilled hole going all the way down through. Now they would just call this a countersink that's a through hole. Okay, so a realistic example, you have these countersink tools. There's different types that they'll look different ways, but basically what this is doing is it's cutting out an angled top. And this is normally used for a screw head to sit down in. So the top of the screw, which is flat, is also flush with the top of the piece of wood or object you're putting it into. Okay, so as you can kind of see, here's your countersink. Here's a drilled hole that goes all the way down through, and the head of the screw has the same angle as that. It will sit down inside. Okay, so the countersink hole still has the measurement for the through hole, and yes, this can be blind, so it doesn't always have to be through, but the hole would actually have to be big enough that the screw could go down far enough that it fits in. Okay, this is the big thing here that indicates the countersink. So if you see a picture with a whole bunch of hole readings, this is the dead giveaway for a countersink. The big V here indicates the countersink top. Okay, and it says the measurement of the countersink, so that's the diameter at the very, very top, and then the degrees at which that goes down on an angle. So the two typical degrees that you will see is 82 degrees and 100 degrees. And I don't know why that is for those 2 degrees. I don't know who specified those originally, but from what I have found is that the 82 is your typical screw head degrees. And if you have a very small area that this goes in, 100 degrees, which is a little bit sharper than this, sometimes they make specialty screws that have 100 degrees. So 82 is your common degree that you're going to go down. Okay, but again, this symbol right here, this V, is the dead giveaway for a countersink hole. Now, very similar to this is called your counter bore. Okay, counter bore. So a counter, once again, it's sitting down in, and bore meaning to like bore into something or cut into something. So this almost looks like two holes in general. So it almost looks like they did a blind hole up at the top and then a through hole down through the middle. Okay, so the counter bore is kind of more or less like a cylindrical blind hole that was cut down into the top. Okay, so a realistic example, a lot of times this is used to hide bolts, okay, with maybe a washer head or maybe a bolt with a nut and a washer at the end. But as you can see, you can do this in several different ways, depending on how far down you actually put the counter bore. You can make it so that, you know, it's just flush with the top, or that it's really sunk in. A lot of times we use something like this, and then maybe they plug it with another material so you don't see it. Okay, so here's a cutting bit for maybe a piece of wood. You have your counter bore. They do make counter sinks like this too, that we hide screws in pieces of wood. But for this example, this is a counter bore. It would cut down in, and then this part here, the actual drill bit, would do the interior hole, whether that's blind or it is a through hole. Okay, so to read that, again, you have that dead giveaway symbol. It almost looks like a rectangle without the top on it, because this is indicating that counter bore portion up at the top. Okay, so you have your interior hole, that's the one that goes down through the middle. So this measurement obviously is going to be smaller than the actual counter bore top. And again, this can either be a through hole or a blind hole. Okay, the counter bore itself, it's saying its diameter of what that is, and then how far down the drill depth of that counter bore top is, and that measurement. Then you have what is called a tapped hole, better known as a threaded hole. Okay, the reason why they call it a tapped hole is because you're actually, a tap and die set is actually what cuts the taps or the threads, cuts them into the actual object itself. Okay, so this is a tap and die set, as you can kind of see, indicating that you are going to be cutting this down into like a metal substrate. Okay, and you can see how those work. Now, to read this, there are several different steps of going through and reading actual thread readings. So typically you'll see something like this. And what I will say is that the pictures that I have represented down here, in no way, shape, or form are these actual measurements. I just put a standard measurement up here, just something, you know, that I just wrote out, and I just simply found pictures offline and photoshopped these arrows and stuff in. So please do not, under any circumstances, think that, you know, this bolt is the actual size that my reading is. But your first number here that you see, it says is called the number that gives the major or largest diameter. So that would be from the very outside of the threads to the outside of the threads. So not how far in they're cut, but the outside to outside. So like I said, these pictures do not represent, or the measurement does not represent the picture. So this is not 1 inch in diameter. That would be a really, really large bolt. Okay, so 1 indicates, though, the major diameter in this case, the first number. The second number is how many threads there are per inch. Okay, so individual threads per inch. The third thing is going to either say UNC or UNF, and this means unified coarse or unified fine. So coarse threads are spaced out and sometimes filed off, so they don't come to direct points. They're a little bit easier to get on and off. And the unified fine are closely spaced threads, and they're very sharp edges. You find a lot of unified fine threads in electronics because they're small electronics and they have a very small area to put as many threads as they possibly can to hold the object together. Like in your phone, you can't have large screws in there. Okay, so you might only get 1 or 2 threads that actually hold it together. Okay, so UNC or UNF. Next, you will have 2 things here. You'll have a number, a ranking of 1 through 5, and that's called your class of fit. A typical class of fit would be a 2 or a 3. So this indicates how sloppy it is, meaning is it going to be a very, very tight fit, or is it going to just be able to screw on and off? Okay, the older the bolt gets, the more worn down the threads get, the worse the thread class of fit gets, so the sloppier it gets. Okay, so that's ranked to the 1 through 5. Typically, you'll see a 2 or 3 there. The next thing is you'll either say an A or a B. Sometimes this isn't even indicated just because it's common knowledge based off of where you're adding the threads to. But A is an external thread, so that is threads that go on the outside of an object. So here is an example of like on a bolt. Okay, a B indicates internal threads. Okay, internal threads. So an easy way of remembering that is B inside. I don't know why my students have done that, but they've said, you know, like AE for American Eagle, A external and B inside. I don't know why they said B inside, but I guess because school's inside. I don't know what they're indicating there, but A is for external, B is for internal. Okay, and next you see I just have a little line pointing to this blank space here. So typically we say righty tighty lefty loosey is the old saying. Okay, so you can have right-handed threads or left-handed threads. Okay, right-handed threads, since that's the typical way of doing it, there is no line. If you see a little underscore like this, that means it is a left-hand thread. And the difference between those two is how you tighten it. You turn it to the left to tighten it or to the right to tighten it. And the reason they would have something like this is normally if you have something that's rotating with this. So for instance, if you think of like tires, you might have a tire on the right side and a tire on the left side of some type of object that moves. Well, the tire on the right side, when the tires move forward, you don't want the threads to be loosening. Okay, so it has to be in the opposite direction. So on the right side of the object, if they are rotating to the right, as it rotates the bolt to the right, you want it to also tighten. Okay, on the left side, you want to use a left-hand thread, so when it rotates forward, which in this case would be to the left, it also tightens. You don't want it to loosen. Okay, so there are a difference between right-hand and left-hand threads, and that is indicated by an underscore or no underscore. Then finally, we have our thread depth. So this isn't drill depth here, this is thread depth like I said earlier, and that is the length of those threads. So that does not include whatever type of head you may have, like a pan head or a hex head or any other types of head there are. It's just indicating the actual threads. So if you're kind of putting some of this knowledge together, which I know is a lot to think through here, just going by this reading, not this actual picture, what this is saying is that there are 8 threads per inch. So if the total thread count is an inch and a half, you would be doing 8 times 1.5. So here we'd actually have 12 total threads on the bolt that is represented here by this reading. Okay, so that is the thread and hole type presentation.